Good morning. I am Dr. A. Kalaiselvi. Today I present the topic resolution and knowledge representation. Here is the definition for resolution. That is, first one is conjugate normal form for first order logic. As in the proportional calculus, first order resolution requires that sentence be an conjunctive normal form, that is ENF, that is a conjunction of classes where each class is a disjunction of literals. Literals can contain variables which are assumed to be universally quantified. For example, the sentence for all x American of x, that is weapon of y, cells of x comma y, and hostel of z, that is it tends to criminals of x, that is it becomes an CNF, that is conjunctive normal form. That is not American of x, or not weapons of y, or not cells of x comma y comma z, or not hostilize of z, or criminals of x. These are all the forms. That is either one of this. There is every sentence of first order logic can be converted into an inferentially equivalent CNF sentence. That is, every sentence must be converted into the equivalence conjunctive normal form. The steps are as follows. That is, first one is eliminate implication, next one is move, then standardize variables, then columnization, drop universal quantifiers, distribute over. Then these are all the steps. Then first one is eliminate implication, that is for all x. Then all others are R cases, not R, Y not, animals of y, or loves of x comma y, or loves of y comma x. These are all of R cases. That is, choose anyone. For all x, choose anyone. That is the animal of, that is allows, or anyone. That is, next one is move, not inverts. That is, not for all x, b becomes their x is x not p. For all x, their x is xb becomes for all x not p. Our sentence goes through the following transformation. That is, for all x, there exists y, not of animal of y, or loves of x comma y, or there exists y loves of y comma x. The brackets are changes. The next, standardized variables. For sentence like there exists, or which are the names variables, names twice, change the name one of the variables. This avoids confusion later when we drop the quantifiers. Thus we have the following. That is, the animals of x and or not. These are all the operators used. Then columnization is the process of removing existential quantifiers by eliminations. The Kloman entities depends on x and y. Here, capital F and G are Klom functions. For all x, that is animals of f of x. F of x is a function, that is not loves of x of f of x. That is, f of x means it is a quantifier, that is. So next one is drop universal quantifier. That is, all remaining variables must be universally quantified. That is f of x, g of x, that all. Then distribute R over. That is, this step may also record flattening out nested conjunctions and disjunctions. Conjunction means and function, disjunction means or functions. The next one is love animal example. One of the example is love animal example. Our second example makes us colonization and involves classes that are not defined classes. The result is a more complex proof structure. In English, the problem is everyone who loves all animals is loved by someone. Everyone who kills an animal is loved by no one. That's the truth. Jack loves all animals. That is either Jack or curiosity killed the cat, who is named Turner. The next, first we express original sentence, background knowledge and negated goals G in the FOM. That is, this is the form. That is for Alex, not and implicity, there exist used in this. Now we apply the conversation procedure to convert each sentence to CNF. Then animal f of x for all loves g of x comma x. That is the functions, that is loves of y comma x are not animals of z or not kills of x comma z. So that is either loves means that is it is not a animal, not kills. That is previously I told this. The next one is completeness of resolution. Resolution is refutation complete, which means that if a set of sentences is unsatisfiable, then resolution will always be able to derive a contradiction. Hence, it can be used to find all answer to a given question. That is g of x by proving that kb for all are not q of x is unsatisfied. The basic structure of the proof is, first we observe that if S is unsatisfiable, then there exists a particular set of ground instance of the class of X such that set is also unsatisfiable. We then appeal to the ground resolution theorem, which states that proportional resolution is complete for ground sentence. We then use a lifting lemma to show that for any proportional resolution proof using the set of ground sentence. That is resolution strategies. The strategies are unit preference, set of support, input resolution, subsumption. Unit preference. This strategy prefers to do resolution where one of the sentences is a single literal, also known as unit class. That is, one of the sentences is a unit literal, or that is a unit class. Every resolution set involves at least one element of a set of support. The resolvent is then added into the set of support in the set. Every resolution combines one input sentence with some other sentence. Then eliminate all sentences that are subsumed by an existing sentence in the KB. The next one is knowledge representation. The steps involved in the knowledge representations are: first one is identify the task, then assemble the relevant knowledge, then decide on a vocabulary of predicates, functions and constants that are used in the sentence, then encode a general knowledge about the domain, encode a description of the specific problem in instance, pose queries to the inference procedures and get the corresponding answer, debug the knowledge base. Then the characteristics of knowledge representation. Representational adequacy, that is ability to represent all knowledge that are needed in the domain. Then the ability to manipulate the structure in such a way that to derive new structure that are corresponding to new knowledge inferred by using the old one. Then the ability to incorporate additional information to focus the new mechanism of the inference. Then the ability to acquire new information easily. Then multiple techniques for multiple knowledge representation. That is simple relation knowledge, that is declare facts in the form of table. Then inheritance knowledge. Then there are several inheritance are there, that is single inheritance, multi-line inheritance, multiple inheritance. That is elements of specific class inherit attributes and values from more general classes in which they are included. Then inferential knowledge implements standard logical rules of inference with resolution. Then procedural knowledge, that is specifies what to do and when. The next, components of good representation. For analysis purpose, it is useful to be able to break any knowledge representation down into 4 fundamental components, that are lexical part, that is syntactical or structural part, semantic part, then procedural part. Lexical part is the symbols or words used in the sentence. Then structural or syntactic part is the constraints on how the words or symbols used. Semantic parts, that is the association of real world meaning with representation. The next, procedural part, that access procedures that generate and compute things which the representation. Knowledge can be represented in different forms as mental images in one's, as spoken or written words in some language, as graphical or other pictures, and as character strings or collection of magnetic spots stored in the computer. That is represented in figurative forms, that is mental images into written text, into character strings, into binary numbers, into magnetic spots. Thank you.